continuous. So, f is continuous at c if and only if the limit as x approaches c, f of x, is equal to f of c. So some facts about this, which is what the facts that I'm about to list are what we're going to use when we're trying to discuss if something is continuous. So, f is continuous at c if and only if 1, c is in the domain. So if it's in the domain, that is in our set of, domain is our set of x values, our horizontal values. Then also the limit as x approaches c of f of s exists, and the limit is equal to f of c. While the definition takes into account that third part, you cannot say it's continuous if the limit does not exist. So that second part is like a precursor, and then the first part is that it's letting you know your C is discussing is what we're looking at as far as our X. And we're going to use these three pieces when we discuss continuity. So let's let f of x equal 5x cubed minus 7x squared I'm going to change this. We're going to do a piecewise. Let f of x equal, let's look at x cubed minus 1 if x is less than 1. And let's look at 3x minus 2 if x is greater than 1. Okay? So we're going to look at this piecewise function, and we want to discuss with respect to continuity. So now, just FYI, moving forward, I may just put WRT for with respect to. Also, I don't know if we discussed, but IFF is if and only if. And that is universal notation. You may actually read that in math text. They may use IFF when talking about it, just like our arrow is for implies. You may see that in math text. Okay, so with respect to continuity. So, the first piece is that has to be in the domain. It has to exist in F. In F. Domain of F. What is C? Like, what are you, with continuity, let's add continuity at 1. So, the first piece says that C has to be in the domain. Is 1 accounted for here? So, the first part, since 1 is not in the domain, then F is not, it should have said not, it's not continuous at 1. Okay? X is not continuous at 1. It's not defined at 1. There's no way to see what 1 is. 1 is not in the domain. So now, let's look. Let f of x equal x cubed plus 1 if x is less than 1. And let's say it's 3x if x is greater than or equal to 1. So, is there a place where 1 can exist? In the 3x, correct? So if I was to substitute in, I get that 1, 3 would be part of this function. So we can say that 1 is in the domain. That doesn't mean it's continuous. That's one of 3 pieces. Anytime we're looking at things, if one of the 3 works, that's great, but it needs all 3. If one of them doesn't work, then we can go ahead and say it's not continuous. So now the second piece says that the limit has to exist. So now to exist, you have to look at it from the left and the right. So we say, since the limit as x approaches 1 from the left, f of x equals, if I'm coming from the left, which part of the function am I going to use? The x cubed plus 1. So then I have 1 cubed plus 1, which is 2. Then we want to find the limit from the right. So coming from the right, we use 3x. So now this becomes 3. Since they are not equal, that means what? The limit as x approaches 1, f of x does not exist. Therefore, f is not continuous at 1. The limit from the left and the limit from the right have to be equal for the limit to truly exist at that number, at 1. Let's see. Yeah, I can fit another one on this page. So now let's look. Let's let f of x equal x cubed plus 1 if x is less than 1. And let's let it be 3x minus 1 if x is greater than or equal to 1. I'm going to put discuss. I should have wrote this. Discuss with respect to continuity at 1. So the first thing we have to do is find out, is 1 in the domain? So f of 1. F of 1 would be the 3 times 1 minus 1, which is 2. So that tells me 1 is in the domain. The next thing we want to do is show that the limit from the left and the right are the same, because if they're not the same, then the limit doesn't exist. So, since the limit as x approaches 1 from the left comes from x cubed plus 1, that would be 1 cubed plus 1 is 2. And the limit from the right is going to come from 3x minus 1, which is 2. Then they're the same, so we can say that the limit as x approaches 1 of f of x also equals 2. So now, looking back at the 3 conditions, the last thing is that the limit as x approaches c f of x has to equal f of c. So, we already said, what is f of c? We did f of c in part 1, and we got 2. And we've said the limit is also 2. So we can say since f of 1 equals 2 and the limit equals 2, it follows that f is continuous at 1. F is continuous at 1.
Here's what I found.
We're good. Okay. Let's look if we have a piecewise function with more than 2. So let's look at let f of x equal x squared plus 1 if x is less than or equal to negative 2, negative 3x minus 1 if x is between negative 2 and positive 1 but not equal to negative 2. And then 2x squared minus 5 if x is greater than 1. So now, in this, we would be discussing continuity at 2 places. Discuss continuity. What 2 places do you think we're going to be discussing continuity at? At negative 2 and 1. So we're going to have to do 2 separate arguments here. So the first one we're going to look at with respect to continuity at negative 2. We'll do negative 2 first. So if we're doing that, we're going to have our 1, 2, 3 discussion here. So first, we have to see, is negative 2 in the domain? So, what is f of negative 2? Where would we even find that out? For which part? The top one. So we would say negative 2 squared plus 1 is 5. So then negative 2 is in the domain. If there was nowhere to substitute 2 in, if none of these had the or equal to, then we would know right away it's not continuous because negative 2 is not accounted for. Okay, now the second piece tells us we need to find the limit from the left and the limit from the right. So as the limit as x approaches negative 2 from the left of f of x, now from the left, we're going to use that top function of negative 2, I need to write it. That was x squared plus 1, which is negative 2 squared plus 1, which is 5. And the limit from the right, we're going to use that middle function. Because we're working with, there's 3 different pieces to the function, I do think it's good to write down this part right here where you're showing the piece you're using. So then when you replace it, what is negative 3 times negative 2 is 6, minus 1 is 5. So since they are the same, then we can say the limit as x approaches negative 2 f of x is 5. So now, if 1 and 2 exist and they're equal, then we're continuous. So our third piece is just to say, since f of negative 2 is 5 and the limit as x approaches negative 2 is 5, it follows that f is continuous at -2. So, to tell if it's continuous at 1, we say, what is f of 1? Which piece of the function are we going to use for 1? The middle. So that's -3 times 1 minus 1, which gives us -4. So 1 is in the domain. The second thing is to find the limit from the left and the limit from the right. So from the left, we're looking at the -3x minus 1, the middle function. And that gives us -4. So far, it looks like, we're on the right track. And so now we want to look, what's the limit as x approaches 1 from the right? So for this one, we want to use the last piece of the function, which was 2x squared minus 5. So that's 2 times 1 squared minus 5. And that gives us -3. So now, because they're not equal, that tells me the limit as x approaches 1 f of x, what? Does not exist. Does not exist. Therefore, f is not continuous at 1.